All right. Hey, everybody. Thank you for waking up. I'm glad that I'm here. I'm surprised that any of you are. Um, I'm Richard Wartell. I work for Palo Alto Networks, and we'll talk a little bit about malware today, ABTs, all of that fun stuff. Just to give you a heads up, I have exactly 100 slides to get through in 25 minutes, so let's do this. All right. We're going to talk about who I am. We'll talk about ABTs a little bit. I'm going to tell a story because stories are fun. And then we'll talk a little bit about APTs that do a really good job. And then we'll talk about how they could do better. And then a little bit about Thug Life. So if you're wondering what a Wartell is, this is a Wartell. I'm a reverse engineer for Palo Alto Networks. And when I ask my friends to draw me, this is what happens. So APTs. What are APTs? The internet just absolutely loves this, and it's exploded in the media lately, and it's kind of horrible. So according to the internet, this is what an APT is. APTs are ninjas in the bytes, and they're reading all the credit card data. So what really happened here is, and sorry, if you Google image search APT, this does come up. So what really happened here is somebody wrote a regex that looks something like this for looking up track 1 and track 2 data out of memory. That's the main thing that happened. And then, oh my God, the internet's like, these hackers are like ninjas riding T-Rexes, flying through the Gibson, reading all the matrix code so that they can create Terminators and take over the world. That was basically the crux of how bad everybody made this crap sound. And that's not really what's going on. What's really going on here is this is much more what an APT probably looks like. However, APTs are all over the place. Like they're different. There are different motivations, different skill levels. So, some APTs are like script kiddies that are just using scripts that they're finding on the internet. Some of them are writing packed kernel drivers. So there's different skill levels. There's different motivations. Some are after intellectual property. Some are just doing reconnaissance. Some are entirely financial based. They're doing PCI stuff. So it's just important to know that there's different levels. And when somebody says APT, they mean a hell of a lot of different things most of the time. It's important to know that sometimes APT looks like this, and sometimes APT looks like this. And also, apparently, sometimes APT now looks like this. It makes no sense to me. So rather than it being APT, maybe we should start calling it PTA. Like, these are persistent threat actors. Advanced is subjective. So with that, let me tell a story. This is Fran. Fran works for the APTs. She writes malware, and she's, got the same problems that all of us have. Like, she's got a mortgage and a family she worries about. She's just a dev doing her thing. This is Barb. Barb works for an IR company and reverse engineers malware for a living. So that's what she does, and she's the exact same. She's just doing a job. And this is Taylor. Damn it, I thought I was keeling over laughing while giving this talk. It's too early. Taylor's Fran's boss. And, sometimes Taylor's kind of a dick to Fran and comes down on her really hard trying to get her to do stuff. So one day, Fran gets a call from Taylor and is like, hey, we got to attack this construction company and get in there. We need to backdoor all the things and steal all of their IP. And Fran's like, okay, I'm going to think about this. I'll work through it. She's also thinking about her kids and putting food on the table and, her marriage and making sure everything's good there and like that dreamboat that she wants to own at some point. So she works really hard and thinks about this, and she's like, I'm going to use... Damn, I got you twice. So she starts working really hard. I'm not getting through 100 slides, by the way, if you keep laughing like this. She starts working really hard, and she's like, I'm going to use public tools. Like, I don't even have to dev anything. I can just use some public stuff. She hears about this cool thing called poison ivy, and she's like, all right, I'm just going to take this. I'm going to make a PDF, and it's going to be great. I'll shove some shell code in this PDF, and we'll just shoot it out everywhere, and it's going to be awesome. And so she spends a couple hours working, and it's like, woo, I'm done. Killed it. She pew-pews it out to the internet and gets it over to where it's supposed to be. And however, that construction company gets a notification. It's like, hey, something's not quite right here, from like the FBI or something happens, and the construction company hires Barb's company. And then Barb gets this piece of malware and is like, hey, this PDF doesn't look quite right because, yeah, obviously not quite right. And that's not an exaggeration. This is as bad as they are sometimes. So Barb's like, okay, cool. I'm going to go and look into this. She starts digging into it. She wakes up and has her morning coffee, and it's just like, okay, time to look into this malware. So Barb starts working, and she's like, all right, I got this. Oh, she runs it, and she's like, hey, that's a mutex I recognize. Oh, I see this traffic. It's like 256 bytes of encrypted traffic for every packet. This looks really familiar. And she's like, I've seen this before. This is poison ivy. She's like, okay, I figured this out. She's done with it in seconds because like this is public tools that she's seen before. She's like, all right, cool. Writes an IOC in a terrible program like this, spits it out there, does the splits, and is like, yes, killed it. Did my job today. I'm winning. However, Taylor's pissed because now they're out. Like they found everything, knocked him out again. So Taylor comes down on Fran. Fran's really upset and like, I'm sorry. But she's like, I got this. I'm going to try harder this time. I'm going to write my own malware. I'm going to kill it. It's going to be great. She's like, all right, I'm going to do this. So it gets back to Barb. Basically, they spit it out there. All malware's out there again. And the construction company gets the malware to Barb. She starts looking at it. She runs it. You know, why not? Let's see what it does when you run it. And she sees this. The malware has usage. That's great. You just told me what your malware does. That's awesome. So that was great. Fran's like, lol, that's amazing. Or sorry, Barb. And she does her same thing, writes an IOC. They do some stuff, knock him out. And Taylor's pissed again. I mean, Fran is worried about her job, her kids, all of these things. But she's like, okay, I got this. I'm going to write some better malware. I think I know what went wrong. Maybe that usage was a bad idea. So she gets there. The malware gets back to Barb. I think if this is... She starts working on it. Oh, damn. And this is what she sees this time. The malware drops a text file that's full of debugging information about everything it's doing. So it doesn't have usage, but when you run it, it still goes through and tells you everything that it's doing as it does it. Because Fran has left all of her debugging strings in there. Not so smart. Barb says lols again. She also sees something else really hilarious. So inside of here, this malware is communicating with a command and control server, and she sees, hey, the communication gets it gets encrypted, and then it gets compressed. Does anybody see a problem with this? So when you take something and you encrypt it, the entropy goes through the roof because the bytes are all randomized. And then when you compress it, compression is based on patterns. Like that's how you can compress items. So you compress it and nothing happens. It's not going to get smaller. Bad compression algorithms will make it bigger if you do this. So pretty awesome. Barb's like, this is awesome. That was hilarious. She and her coworkers go out for some drinks. So side story. Yes, I did buy 3 Barbies for this talk. Yeah, my girlfriend found me on the floor of my office playing with Barbies one day and giggling, and she thought I'd gone insane. It was pretty great. So Taylor's really mad again. Fran's like super scared, but she works hard and she's like, all right, I know what went wrong. I did some dumb things. I can do better. So malware gets back to Barb. All those debugging strings are gone, and Barb is like, oh, nice. More interesting. I might actually have to do some reversing work. Then she actually looks into the binary and starts reversing it. And she sees this. The printer function doesn't do anything, so this is like, she sees a function having a string pushed to it, but that function doesn't do anything. However, it's basically like Fran has marked up the whole binary for her, so like I don't need to do any work in the IDB because it's all marked up. There's these debugging strings right around all the cool, interesting things. So I could just, well, nice. It's like commented code, but it's a binary. Pretty hilarious. Barb says lol again. This is great. Her boss is like, dude, you were killing it, Barb. This is awesome. Well done. She goes out for a beer. You know, she's having good times. However, Taylor is not exactly that happy. So, you know, Fran is scared about all the things that are going on in her life and what's going on and how she's, you know, not doing that well at her job right now. But she thinks about things and she's like, okay, I got this. I got some cool ideas. I can do this. She's like, writes something that she's really proud of. It gets to Barb. She's working in her spaceman suit today. And Barb looks at it and says, okay, this is more interesting. This is harder. It's not, there's no debugging strings. There's nothing like super easy about this. However, then she goes and she sees the network traffic that this is creating, and it looks like this. Now, this may look very simple and nothing's wrong here. However, that is wrong. There's a space missing because Fran has not copy-pasted that all that well. Because there's that space missing in between, after that semicolon, you can write a network signature because Mozilla's traffic, or Firefox's traffic is never going to look like that. That space should be there. You write a network sig and suddenly catch it every time. Taylor's pissed again, like, God, come on, Fran, do better. And she's scared, but she thinks about things and she's like, okay, I can work through this. She finally writes some damn cool malware. So what she does to fix this is she actually searches through the Windows registry and says, okay, what version of a web browser is running? She checks for that, she finds that information, and then she has all of the user agent strings for all of those, and then she injects into that, she launches that browser, injects into it, and mimics the traffic, mimics the user agent, and he does it that way. Pretty smart, and does a really good job. So now we have very, very good way of hiding. So Fran sees all that, and it's like, oh, that's pretty cool. Like, you can't network sig that. It looks really good. However, she sees some other dumb things that make it really easy to find. So the command and control structure here, there's always a command loop in a backdoor. And she goes and she starts looking through and she sees this. If Fran ever tries to change the configuration for this malware, which like there's an option for, you know, when she's communicating with it to change the configuration, like use a different command and control server. Yeah, it's broken. It's absolutely broken and will crash the malware if she tries to do it. So that makes Barb lol. Then she looks a little closer and she sees something even better. Does anybody know the first rule of crypto? Do not roll your own. Thank you very much. And there's been a great example of this that I'll go over in a second, but you don't roll your own damn crypto because trust me, the people that wrote the crypto algorithms that you can use publicly are probably better at it than you are. Like, it's just true. So this makes everybody lol. And then it gets even worse. So in Fran's malware, she goes through and she's like, oh, she's going to actually look through all the open file handles on the system and find the one for her malware because she knows the size of it and she checks the size of it to see where it is. So she tries to find it, go and get to the end of that malware. So she just seeks to the end of that malware, and there's data that's not being loaded as part of the PE that's actually just in the raw file on disk. However, she does this and she has like the encoded C2 information at the end of the file. She does this based on a certain file size for a certain domain that she did for testing called evil.com. But then when they deploy, she changes it to superevil.com. And she doesn't change her file size. And her backdoor never fires. And now Barb's just like, this is amazing. Taylor is super upset. This is not going well. And Fran's like, this is terrible. She loses her job. She has to move. And then Barb goes out and has a party with her friends. I don't have an elegant end for this story, so I'll take a small bow. So this is obviously like an exaggerated story. Like, this isn't. However, every single one of those pieces of malware I was talking about, that's stuff I've seen in the wild. Like, that's all realistic things that happen. These are devs out there that are making silly mistakes just like the rest of us. They're not crazy ninjas. Some of them are. So let's talk about some of the cool malware that's out there, some of the clever things that have been done. So one of the first ones I like to talk about is one I saw where the malware actually implemented an entire shell inside of itself. So rather than just creating a reverse shell out of like 100 lines of code, they implemented all the functionality of a shell internally to it. So it was a backdoor with commands that were all of the commands for like a whole shell, including things like netcat, ipconfig, and other things that are, you know, not default in a shell. So kind of cool, really interesting. A lot of work for what you could do with a reverse shell, but still pretty cool. Another one that we saw that actually the person that analyzed this is sitting right there. His name's Matt Graber. He's a smart man. He saw some malware where it was an executable where as it executed, it checked if it was running on 32-bit or 64-bit architecture, and it had 2 different shellcode payloads and would run one or the other based on which architecture was running. So that was also pretty cool. One of my favorites that I saw was a really tiny binary. Well, it was a large binary full of red herring code, or like code that doesn't do anything. It was just there to distract you. So that it would just execute all that stuff, and it would slowly build a tiny shellcode buffer. And that shellcode buffer was just a download and execute program whose sole focus was to download one module, execute it, and that would then download and execute more modules. So a very tiny, very modular, and that it's tough to analyze because unless I get those modules, I can't see it. I don't know what its end goal is. So still pretty cool. Then I recently saw some stuff that was pretty awesome where I saw what I'm almost positive, I can't prove this, but this is what I like to do when I'm writing obfuscators and things, is I saw what looked like somebody was writing code that wrote code for them. So they were programmatically generating things so that rather than them having to hand create them, they were making a program to do it for them. So what I saw was I started reversing a sample, and the encoding was definitely custom. It wasn't something new, but it was more complicated than any sane human would probably put together. So this was one of the multiple encoding loops that were involved in it. However, it wasn't any mainstream encoding. It was just a bunch of different binary operations that looked very much programmatic and random, which was pretty cool. Like, I hadn't seen somebody doing this before, so it was kind of cool to see that. Makes it a pain to reverse. And then in that same sample, they had written something that was a command loop that it was really difficult to get the sample to beacon. So you start digging in there, you find the command loop, but if you're running this, you can't get it to beacon. What was happening was the malware actually had another programmatically generated function that had all kinds of sleeps and waits and different things that were all based on a state machine. And that state machine would say, okay, based on the state I'm in, move to the next state, and it would randomly go to one of these states. And eventually, it would get down to the state of executing the command loop. However, most of the time, it's just going to go and create threads and wait for them to finish, or call sleep, or do some math. It was really cool because it would execute, and if you ran it, it's not going to do anything most of the time. It's just going to sit there and wait, and then eventually, just by the power of math, it was going to execute its command loop. So pretty cool. Hadn't seen that before. There's actually a blog post that Rob Falcone and I did about this. It's a backdoor family called Perpy that actually has like evolving protections, which was kind of cool. And then my favorite one to talk about is one that we saw in an investigation where there was an evil service, and that service was pointing to a packed kernel driver. So that the packed kernel driver would launch, unpack itself, and then inject into userland code. So it would do that and have all of these malicious processes, and it's things like Explorer and CSRSS and all of these malicious userland processes, and then it would on purpose crash. And it would go away. So all you had was your userland processes were infected, and it's like there's not anything running that you didn't put in there. And the kernel driver is not even there anymore. So kind of awesome, really cool to see. However, there was some ridiculous silliness to this. This is a packed kernel driver, but they didn't figure out a way to sign it. Most kernel drivers are signed. Like, it's a kind of glaring red flag. On top of that, so it's unsigned. The file name was a random character string. Like, you also usually don't see that. The service name was a random character string. And then the description was Microsoft, the random character string support. That, Microsoft signs their shit. I mean, that's just silly. So yeah, that was what was going through my brain when we saw this. And then even better, their end goal was to wrap a .NET string copy function. That was all they were after. This was a PCI thing. So they were just trying to wrap a .NET string copy function. So they're trying to wrap a .NET binary. You can decompile .NET really easily. It's almost, there's obfuscators out there, but most of the time decompiling it and recompiling it, pretty easy to do. So you can either decompile that and recompile it, and it's changed a little bit on disk, or you have an unsigned pack kernel driver called Microsoft Random Character Name Support. Yeah, just a little ridiculous. This is when we were like, these might be dog scientists we were dealing with. So, all right. Finally, the last thing I want to talk about is ways to do this better. So, there's a lot of ways to protect your code, from reverse engineering. There's anti-RE techniques, and there's ways to just have better practices for like when you're writing things. So if you're in a red team and you're writing malware because you need and you want to make it difficult for your blue team, or just to troll them, like have fun with it. So the first one is just use ifdef. Like if you're writing this in C, if you're going to use debugging strings, just wrap them in an ifdef, and then when you deploy, it takes changing one thing and all of them go away. So use pre-compiler stuff. It's a great option. And also, there's even more clever ways to do this, like print a fake usage. Mess with me a little bit. Like you could use the usage from ping and say, that's it. This might be ping. Like I might make a mistake on that. Like, so, mess around with that kind of stuff. Even better, like use interesting debugging strings that make absolutely no sense. Like start a hadron collider, like whatever. And finally, next, check all of your strings in your binary. Ripping strings out is really easy. If I see a weird user agent, it's really easy to network sig. If I see super awesome backdoor, oh my god, as like your project path because you wrote this in Visual Studio and it shoves that in there, it's bad. You're telling me things. Stop doing that. Next, XOR. Does everybody understand how the math of XOR works? Awesome. So XORing is great. It's an invertible mathematical function. This is like simple explanation of what happens when you XOR things. However, it doesn't protect you. It's actually pretty ineffective in terms of hiding contextual data a lot of times. So I have a very great proof of concept of this. If you take a threat butt and you XOR it with YOLO threat, it still looks like a threat butt. So it doesn't protect you that well. It's pretty obvious that you can, when you XOR things, you leave data because you're not changing. It's not, it doesn't raise entropy a lot of the times, or it all depends on like the data that you're dealing with. Like if you have a lot of 0 bytes and you're using an XOR, it's often you're showing me exactly what the key is. So just note that. And it's also really easy to use mainstream crypto and stuff like that. Or create your own custom encoding. Like I was describing with that programmatic generation, you can create something that makes an invertible function. And that is really not that hard to do. You just have to do some math, and then it's more difficult to reverse and more difficult to get your data out that you want to protect. Don't reinvent the wheel. Like Themida and VM Protect are terrifying packers. Don't write your own. You'll probably do a worse job than most people. Than some of the really good ones out there. And like I was saying, use mainstream crypto. Also, choose a programming language that's interesting. Like C and C# are bad choices most of the time because they decompile really easily. There's a lot of work that's been done out there to get them to disassemble and decompile very, very easily. So use things like Delphi. Delphi is this old, outdated language, and it's terrifying and ugly to reverse. It was just a horrible compiler, and yeah, it's a pain. C++, with a lot of object-oriented and function pointer passing, makes it really annoying to reverse. Also, Golang is annoying to reverse. Like, play around with that. I'm also told that Rust is a real pain. So, next, hide your communication. Like I was saying, like if you have very obvious network strings, it's bad. So like when you're sending back data to your C2, hide it a little bit. I mean, and also you can use things like public comms, like use Twitter and WordPress and Facebook and LinkedIn APIs. Like you can have fun with that, and it makes it interesting to work with. And also, and last, just be a little more clever. So, switch between different network communications, troll a little bit, like hide in very similar code so that if you're using, network communications, hide in something that also does network communications. And, pretend to be something else. Like you can do some cool stuff there. And then you can write modular malware. Like I was describing earlier, if the malware downloads pieces as they need them, it's much harder to reverse unless I get all of the pieces. I won't know everything that's going on. So just make modular things and download new functionality. Or write rootkit backdoors. Rootkits are much harder to write, but much harder to reverse. It's a good way to protect your stuff. Or write a BIOS backdoor and, propagate via sound waves. Apparently that's a thing now. And like I was also saying, write code that writes code. It's actually fun. Write some obfuscators. It's pretty entertaining to do. I'm a very big fan of writing Python to write other things for me. And then finally, just don't be this guy. Don't be lazy. Like, think about what you're trying to accomplish and accomplish it. I mean, we're often under the gun a lot in terms of what we're doing, but you can write good code if you're just thinking about what you're after. So you just don't want to be this guy. And you, sorry, you may be asking, what if all of this is the case and it's so tough to be the APT, who would want to do it? And this is the only reason I can come up with. and with that, I'll take your questions. Also, I have 2 newly printed t-shirts that look like this if you are interested in them, and first 2 questions can have one.
Can I have a shirt?
No.
Has anyone ever been so far? Yes.
You get a shirt.
Has anyone used
Thank God, no. But I just saw that talk and I loved it. I thought it was awesome. I'm terrified of it. Yeah, it's disgusting. And yeah, so he was asking about Movehiscator, which is another guy gave a talk on, where they made an obfuscator where it takes the whole instruction set, and the move instruction is Turing complete, so it takes everything and turns it into just moves. There's not even at the end any non-move instructions. So when you bring it up in IDA, it's a line. It's terrible. I mean, so like figure this out. It's 500,000 move instructions. I don't like. In his talk, he's like, if I was REing this, I would see this and be like, nope, just mic drop. I'm out, done. Yeah, terrifying. So, and you get a shirt. Anybody else? Awesome. Thank you very much for your time.